In the star-rich social occasion Orion, there is a star that has charmed cosmologists for a genuinely extended period of time, Betelgeuse. This red, extraordinarily tremendous star is much more noteworthy and more monstrous than our Sun. In recent years, Betelgeuse has been acting especially oddly. It has decreased considerably and has even begun to vibrate brutally. This has prompted speculation that this once-rich star is moving toward a pompous impact. Yet, think about how possible it is that we are really seeing the beginning of a more misleading and upsetting event. Consider the likelihood that Betelgeuse won't detonate, but rather break down on itself. Join us as we investigate the most recent examination on Betelgeuse and its expected ramifications for our planet. Through this research, we aim to understand the significant impact Betelgeuse's breakdown could have on the fate of the universe. The special secrets of Betelgeuse. Betelgeuse is a huge star, many times greater than our Sun, and is among the universe's largest. However, its size comes with a cost. Stars like this have limited lifespans, and Betelgeuse is no exception. It's a ticking time bomb, prepared to detonate. But the exact moment remains a mystery. Located around 650 light-years away, Betelgeuse has astonished cosmologists, shining as one of our closest stars. We marvel at its splendor, attempting to unravel the mysteries hidden within its red-hot depths. However, only 13.3% of its radiant energy is visible to us. If we could see its full magnificence, it would outshine even Sirius in the night sky. The grand life cycle. Imagine a titanic star with a radius typically that of our Sun, growing past the asteroid belt and almost touching Jupiter. Within this vast region, Earth, Mars, Mercury, and Venus would be immersed by Betelgeuse's colossal gravitational force. But the surprises don't end there. Every few hundred years, Betelgeuse sheds a solar mass, pushing off its outer layers in a brilliant display of grandeur. A cloud, typically larger than the star itself, envelopes Betelgeuse, covering it in an ethereal haze that captures our gaze. This cloud, growing 30 light-years in size, invites us into an awe-inspiring celestial dance, urging us to uncover its mysteries. The core of the star. We ought to plunge further into the core of Betelgeuse, where the nuclear fusion of hydrogen creates helium in a massive reaction. Over time, the star's hydrogen fuel diminishes, leading to a glorious transformation as helium fuses with carbon, emitting light that travels across the universe. However, even this magnificent fusion has its limits. As neon combines with iron, a tremendous change occurs. The star's gravity, weakened by the loss of energy, sets off a looming collapse, pushing Betelgeuse toward a fate that is both spectacular and sad. A cosmic explosion. The fate of Betelgeuse. Stars go through a mesmerizing change, progressing from the lively blues of youth to the blazing reds of development. During the 2nd century BC, Chinese astronomers saw an exceptional apparent phenomenon. Betelgeuse's distinctive yellow shade set it apart from the celestial tapestry. As the centuries unfolded, the baton of observation passed to Greek and Roman astronomers, such as Ptolemy, in the 2nd century AD. In his detailed records, he described Betelgeuse as having an orangish or tanned appearance, a characteristic that still captivates us today. This persistent tone, noted across various cultures, including medieval observers in the Middle Ages, adds to the intrigue surrounding Betelgeuse. A new twist in the story. The tale of Betelgeuse takes an unexpected turn as we dig deeper into its eccentric behavior. In 2019, the star astonished researchers by unexpectedly dimming. Scientists initially believed that a massive dust storm released from the star's surface had obscured our view. However, the origin of the cloud remains unclear. Some researchers speculate that a massive object, like a planet, may have disturbed the star's surface or even been swallowed by it. Recently, Betelgeuse has become twice as bright as its usual brilliance. This may be surprising, as stars typically dim as they age. Researchers are uncertain about the cause of this sudden increase in brightness, but they do know that stellar luminosity can fluctuate due to various factors. Some stars go through cycles of bright and dim phases. Betelgeuse is classified as a variable star because it changes in brightness, growing and contracting regularly, which alters how much light it produces. This is a common occurrence with many stars, including Aldebaran and around 30 other stars visible in the night sky without a telescope. The cosmic blast. Within Betelgeuse's core, a seismic shift was occurring, with material being ejected into space, creating an immense dust cloud of gigantic proportions. This dust cloud obscured a significant portion of Betelgeuse's brilliant light, transforming it from a dazzling guide to a dimmer light in the night sky. Betelgeuse's brightness dropped to levels previously unthinkable. Once considered among the 10 brightest stars, it now ranks lower than the 20th brightest. Recently, Betelgeuse's behavior has stunned astronomers, challenging the rules of stellar dynamics. Speculations abound, trying to unravel the mystery of Betelgeuse's remarkable behavior. Some suspect that massive sunspots or dust clouds are responsible for its dramatic variations, while others are exploring the possibility of cyclical patterns. Their research has led to the disturbing thought that Betelgeuse's vast explosion might have already happened. Yes, you heard that right. While past estimates predicted its cosmic blast event to be centuries away, current evidence now suggests a different story. The cosmic blast is considered one of the final events in a star's life. The Kepler supernova, a massive explosion observed many years ago, provides an example. Researchers have proposed a model suggesting that Betelgeuse is in the late stages of carbon fusion, indicating it might be approaching a significant explosion. This places it as a strong contender for the next expected stellar explosion in our Milky Way, like a grand finale in a cosmic orchestra. Exploring Betelgeuse's role in cosmic evolution. However, studying Betelgeuse is like solving a puzzle with conflicting observations. There are signs of material eruptions and subsequent recovery, hinting at a mass ejection event, but on a smaller scale compared to our Sun. Observational challenges and cosmic explosion visibility complicate the matter. The difficulty lies in our current inability to observe Betelgeuse with precision. Researchers have been studying Betelgeuse for years and have found that its brightness has fluctuated over time, suggesting that the star is aging and could explode soon. However, there is insufficient evidence to predict exactly when this will occur. A supernova is an incredibly bright event that happens when a star dies. It is not dangerous to life on Earth and is safe to view from our planet with the naked eye. Understanding Betelgeuse's role in stellar evolution. Betelgeuse, a red supergiant in the Orion constellation, plays a significant role in the life cycle of stars within our galaxy. Its evolution offers a window into the future of other massive stars, providing crucial insights into the end stages of stellar life and the impact of supernovae on the cosmic environment. To fully understand Betelgeuse's significance, we need to delve deeper into its stellar structure, life cycle, and the broader implications of its potential explosion. Stellar evolution and supergiant stars. Betelgeuse, classified as a red supergiant, is the result of the later stages of stellar evolution. Unlike smaller stars, which burn through their hydrogen fuel more slowly and enter a red giant phase, massive stars like Betelgeuse consume their nuclear fuel at an accelerated rate. This rapid consumption leads to the expansion of the star's outer layers and the formation of a supergiant. The core of Betelgeuse is primarily made of helium and heavier elements like carbon and oxygen. As the hydrogen in the core is exhausted, fusion reactions begin to occur in the outer layers, causing the star to grow. This process is governed by the delicate balance of gravitational forces and radiation pressure, which ultimately results in the star reaching its supergiant stage. The fusion process at the center of Betelgeuse continues to drive its brightness and size. Initially, hydrogen fuses into helium in a series of reactions that release tremendous amounts of energy. As hydrogen is depleted, the core contracts under gravity, increasing temperature and pressure, allowing helium to fuse into heavier elements like carbon and oxygen. The star's outer layers expand dramatically during this stage, resulting in its immense size and characteristic red color. In supergiants like Betelgeuse, this process is more complex due to the star's high mass. The core goes through multiple fusion stages, creating a series of concentric shells where different elements are fused. Each stage of fusion alters the core's structure and energy output, influencing the star's dynamic behavior and potential instability. The supernova mechanism. When Betelgeuse exhausts its nuclear fuel, it will no longer have the energy to counterbalance the gravitational pull of its own mass. This will lead to a dramatic collapse of the core, triggering a supernova explosion. The supernova mechanism involves a series of rapid events. 1. Core collapse. Without sufficient pressure from fusion reactions, the core collapses under its own gravity. This collapse happens at a staggering rate, compressing the core into either a neutron star or a black hole, depending on its mass. 2. Shockwave propagation. The collapse generates a massive shockwave that travels outward through the star's outer layers. This shockwave heats the surrounding material, causing it to explode in a brilliant burst of light and energy. This explosive event is what we call a supernova, a cataclysmic release of energy that can briefly outshine an entire galaxy. The aftermath of a supernova. After a star undergoes a supernova, the remaining core may become a neutron star or collapse further into a black hole, depending on its mass. The outer layers of the star are ejected into space, enriching the surrounding interstellar medium with heavy elements like iron, nickel, and oxygen. These elements become the building blocks for new stars, planets, and even life forms in the universe. In this way, the death of a massive star like Betelgeuse contributes to the ongoing cycle of stellar birth and death, fueling the evolution of the cosmos. The light from a supernova can travel across vast distances, and astronomers can detect these explosions long after the event itself. When Betelgeuse eventually goes supernova, it will likely be visible even during the day from Earth, though it's not expected to pose any danger to life on our planet. The explosion will not directly impact us, but it will provide scientists with a unique opportunity to study the dynamics of stellar death and the formation of elements in the universe. Betelgeuse's legacy in stellar evolution. Betelgeuse's eventual supernova will offer a profound insight into the life cycle of massive stars. By studying stars like Betelgeuse, astronomers can better understand how stars evolve, the processes that lead to their death, and how the elements necessary for life are created and distributed across the universe. Its explosion will be a cosmic event of immense significance, not just for the study of astrophysics, but also for our understanding of the origins of the universe itself. Furthermore, the study of Betelgeuse and other similar stars gives us clues about the future of our Sun. While the Sun is much smaller than Betelgeuse, it too will eventually run out of fuel and expand into a red giant before shedding its outer layers and leaving behind a white dwarf. However, the process will take much longer, and the explosion of Betelgeuse provides a glimpse into the dramatic fate of more massive stars. The potential for observing Betelgeuse's supernova. As astronomers continue to monitor Betelgeuse's behavior, the likelihood of witnessing its eventual supernova increases. While we may not know exactly when the star will explode, scientists are using a variety of tools to study its fluctuations in brightness and other unusual behaviors. By observing these changes, astronomers hope to predict the star's ultimate fate with greater accuracy. Betelgeuse's supernova will be an extraordinary event that captures the attention of both scientists and the general public. With modern telescopes and observation technology, we will be able to observe the explosion in unprecedented detail, gaining valuable insights into the final moments of a massive star's life. It will be a spectacle like no other, and its impact on our understanding of the universe will be immeasurable. Conclusion. Betelgeuse, the red supergiant star in the constellation Orion, continues to captivate scientists and stargazers alike. Its dramatic behavior, including fluctuations in brightness and the possibility of a future supernova, presents an exciting opportunity for astronomers to study the processes that govern stellar evolution and death. While we may not know exactly when Betelgeuse will explode, its eventual fate will provide valuable lessons about the life cycle of stars, the creation of elements, and the ongoing evolution of the universe. As we continue to observe Betelgeuse, we are reminded of the fleeting nature of stars and the vast, ever-changing cosmos in which we live. The eventual explosion of this magnificent star will mark the end of one chapter and the beginning of another in the cosmic narrative, and it will undoubtedly leave an indelible mark on our understanding of the universe.